Course 3, Lesson 120 is all about rationalizing a denominator, which means that we have a radical that is part of a fraction, and that radical is in the denominator, and we can't leave it like that. So this is just going to be a quick lesson of how we, what we call rationalize the denominator. So complex fractions can also have square roots. So just like lesson 119, we can have complex fractions with fractions in the denominator and numerator, but complex fractions also could have a square root or a radical in the denominator. We can't have a square root in the we can have a square root in the numerator, but we can't leave one in the denominator. So express the base and height with a fraction that has a rational denominator. So we want to take this triangle, and we see that this base here is 1 over root 2, and the height is 1 over root 2. We cannot leave it like that. We need to rationalize the denominator. And this is how we do it. We take our fraction, 1 over the square root of 2, and say, how do I get the square root out of that denominator? Well, the only way to truly get rid of a square root is basically squaring what we have, which means I need to do root 2 times root 2. We need to square it, which means I can't just multiply the denominator by one thing. I have to multiply by the numerator as well, which means to rationalize this, I need to multiply by my denominator, that radical, on the numerator and denominator. What happens is on the numerator, we get the square root of 2. Now on the denominator, square root of 2 times square root of 2 is square root of 4, which just simply simplifies to the square root of 2 over 2. And we have rationalized the denominator because we no longer have a radical in the denominator. So each of these side lengths here is actually square root of 2 over 2. All right, let's try another one. So let's try each of these, and we would say if I want to get rid of this root 5, then I have to multiply by it in the numerator and denominator, basically squaring that radical and having opposite operations here and getting rid of it. So on the numerator, I can't really multiply the 3 and the 5. The 3 stays outside of the root 5, but on the denominator, I get the square root of 25, or we reduce, and we need to 3 root 5 over 5. How about this next one? We multiply by the denominator, so root 3 over root 3. So we get 6 root 3 over, well, the square root of 9, which is just 3, and then we see we can simplify a little bit. This 3 and 6 can simplify to just a 2. So this simplified answer is actually just 2 root 3. That's another reason that we rationalize, not just because we don't like square roots in the denominator, but we can get a much simpler answer by rationalizing. Okay, we see radicals in both numerator and denominator, but our process doesn't actually change. We still multiply by that radical in the denominator, so root 2. We get, well, root 3 times root 2, I can multiply those and get root 6 over the square root of 4, or just 2, and I leave it just like that since the square root of 6 can't be simplified anymore. All right, let's try these ones. I would encourage you to stop the video right now and try these out for yourself. I'm just going to quickly go through them because it's the same process as above. Root 2 over root 2, I get 3 root 2 over 2, and I leave it just like that. 2 root over root 3, I multiply by root 3 over root 3 equals 2 root 3 over 3. I multiply by root 2 over root 2, I get 4 root 2 over 2, which can simplify to just 2 root 2. And lastly, root 3 over root 3 is the square root of 3 over 3. And I leave it just like that. Those are much nicer numbers to work with in math rather than our original numbers. Okay, just a couple more here. On these ones, even though the denominator is not actually simplified, that's okay. We'll simplify it once we rationalize the denominator by multiplying by root 8. I get 8 root 8 over 8. These 8s simplify, but I do need to simplify that square root of 8 by putting it in its prime factorization, which is the square root of 2 times 2 times 2, which is just circle and pop, 2 root 2. All right, How about square root of 2 over root 3? I multiply by root 3 over root 3. I get the square root of 6 over 3, and I leave it just like that. How about this one? Root 2 over root 2. And I would get, well, that 2 stays on the outside, but I can multiply the root 2 and root 3 to get root 6 over 2. The 2's cancel out, and we get just root 6. And lastly, 5 over root 10. Square root of 10 over root 10 equals 5 root 10 over 10, and simplify the 5 and 10 to 2. Our final answer is root 10 over 2. All right, that's all of the official ones. I just want to show you one other example of this, which is what if you had something like 2 root 5 over 3 root 2. Well, I wouldn't have to multiply by all of the denominator here, just the radical of root 2 over root 2. What this ends up happening, what happens is we get 2 root 10 on the numerator, just like normal, and 3, I'll just say it right here, 3 root 4, which simplifies to 3 times 2, or 6. So we can now simplify the 2 and the 6 to get root 10 over 3. Okay, so if you have an extra number in that denominator, just multiply by the radical. You could multiply by 3 root 2. It would just mean more simplifying at the end. All right, well, that is the end of lesson 120. Very simple lesson to end with as far as rationalizing the denominator. I hope this video helps with your homework and for studying.